basic means we'll see the idea of basic calculus. So basic calculus when it comes to the picture. Now, suppose that I have kind of a person is walking and he's walking at a speed of 5 kilometers per hour, constant speed. So, how much distance he has walked in 10 hours? So, 5 into 10, that is 50 kilometers he has walked. So, that means that every hour he is collecting 5 kilometers. So 5, 5, 5, 5, 10 times, that is 50. Or if we go for multiplication, 5 into 10, 50. So addition, then multiplication, same thing. Now, a person walking at 5 kilometer per hour, he is collecting 5 kilometer every hour. So 50 kilometer he is collecting in 1 hour. So that in 10 hours. So that is the calculation. Suppose that his velocity is growing. He started with 0. Now at the end of first hour, his velocity is 1 kilometer per hour. At the end of second hour, his velocity is 2 kilometer per hour. At the end of fifth hour, his velocity is 5 kilometer per hour. How much he has collected at the end of 10th kilometer? Okay, so it is growing smooth. Multiplication summation cannot. Multiplication cannot. It's a summation only. So first kilometer, how much he has walked, second kilometer, third kilometer, we have to add. If it is continuous, then we can multiply it. But now we cannot do. So here calculus comes into the picture. Basic calculus. The basic calculus when we have dependent variable, that is the means how much what is the velocity, and independent variable is time. So at each time, what is the velocity? If this is the situation, it is like that, and it is in term of some equation. Like here, if I say the speed is v, then v equal to t. Now, at the end of one first hour, it is 1 kilometer per hour. At the end of second hour, 2 kilometer per hour. At the end of fifth hour, it is 5 kilometer per hour. At the end of 10th hour, it is 10 kilometer per hour. Now, if this situation comes continuous fashion where the relationship between independent and dependent component are through complex function, okay, a function over independent variable brings dependent variable. In that sense, we go for area mechanics. So it is nothing but if I draw the graph, then whatever the area comes into the picture, that is the distance. Same thing, if it is 5 kilometer per hour, then graph is pure rectangle. So 5 into 10. 10 is the time and 5 is the base and 5 is the altitude. So 5 into 10. Now if it is going in a triangle fashion, so base is 10 and height is 5. So it is half of the rectangle. So half into 5 into 10. Okay, so now if I say it, he is going in sinusoidal fashion. He started with 0, but the way sine wave grows, so v equal to sine t. So velocity grows the way sine grows. If these are the situation, then how you will calculate the area of sine? It is not easy. Now triangle it we calculated, but how we calculate the area of sine? So we go step by step. Everything complex thing sits upon simple. Very simple things, more. This is called deep learning in artificial intelligence, where you have kind of a concrete simple thing. Based upon that, you keep making the abstract layer. So sine theta, if we say that down the line, it will come to simple triangle and rectangle. But whatever. Now, if v equal to t, then integration of v would give the distance, that is t square by 2. Okay, if v equal to t, then it is t square by 2. Now, t square by 2, if I want uh, v equal to t, so t is 5, so 5 square by t. Okay, now the equation is that it is 0 to 10. So if it is 0 to 10, then means the total time is 10. So t square by 2. So at the end of 10th kilometer, at the end of now we are talking about at if he's walking, he is growing at t, means at the end of fifth hour it is 5 kilometer per hour. At the end of 10 it is 10 kilometer per hour. So the triangle is 10 by 10 actually. So t square by 2 means 100 by 2, that is 50. If I calculate through triangle way also, half into base into altitude, so 10 into 10, same 50. So the calculus comes into the picture when we have relationship between an independent variable and function over independent variable as as an equation, in terms of a equation. In that case, actual calculation happens with the area only as far as integration is concerned, and differentiation is opposite. If this is the area, then what is the equation of the line? Integration, if this is the equation of the line, then what is the area? Differentiation is just opposite. So now I will talk that how we know that a function is differentiable. That comes in question. Okay, if I say that the integration of t is t square by 2, then can we say that t square by 2 is differentiable? T square by 2, if I differentiate, it comes back as t. How I know that function is differentiable? That comes at question. This is basic calculus. I have an equation of a function. Now if I draw t, then it will go as a triangle. Okay, if I say that v equal to t or y equal to x, then as x is rising, y is also rising. So it is nothing but it is a slope that would lead to a triangle, half of the rectangle. So if I say now the integration is x square by 2, if I have equation like x square, okay, this is x axis. Okay, so if this is x axis, then x square will be like this. Okay, so if this is x axis, then if I say y equal to x square by 2, then it is the equation like that. Then in that sense, if this function, if I differentiate it, it become 2y, it become y, it become x. So y equal to x square by 2, it will become x. Same what we integrated x to bring it x square by 2. Differentiation is just opposite. Now question is, if I say y equal to x square by 2, how I am sure that it is actually differentiable? How a function is called differentiable? Now question arises that function is continuous or not. Not necessary that if function is continuous, then it is differentiable. But if it is differentiable, then certainly we can say that function is continuous. And it follows the signs of limit and continuity. That comes into the picture. Like if I have a surface, okay, like if I have a surface, okay, so one is x-axis and one is y-axis. If this is the surface, then this is x-axis and this is y-axis. Then whatever we get the value against x and y, fxy, that is the z in vertical direction. Now, suppose that there is a point here called a comma b. Can I ask, now I know that function fxy, the x is something, y is something, both are independent variable. Then in that sense, fxy, that is z. So z equal to fxy, that is function over x and y. If that is the case, then can I know that fxy is continuous or not? That is the question. Now at any point a comma b, okay, so it is may not be continuous, like the place where this a comma b is there, this stick is at a comma b, this is a comma b. Now this side of a comma is flat, means whatever the value, this side what we see is same, predictable. But immediately after a comma b, there is a mountain. Can we see? This is a mountain and right side is filled. Okay, so it is something like this is a flat surface, means z value is flat. At this point there is a mountain, or at this point we can see. So at a comma b, if I calculate the differentiation, then what we do, differentiation if I want in a direction, x direction, then fx plus delta xy minus fxy by delta x, that is partial differentiation along x axis. If along delta x, okay, if I add delta x, at that time value suddenly it rises, then this is not a continuous function, right? Means it is going like this. Suddenly you see mountain, or it is a kind of it is some pyramid. So function is not considered as continuous function. In that sense, it is not differentiable. Okay. Now there is no limit exists. So what is the concept of limit, continuity, and differentiability? So that we are seeing. Now suppose that this is a surface, and surface has a hole. Just along the hole we have a comma b. Now right side of a comma b is a hole. So again it cannot exist. So the surface is not continuous. Okay, if there is a hole, or the surface is here, and after that it is a big hole. Can we see the surface up till here, where x equal to 5, suppose x equal to 5, beyond x equal to 5 there is a kind of ditch, then it is not continuous. Up to 5 only, there is a reason, we can say in this region it is okay, but beyond the region it is not continuous. So if function is not continuous, then it is not differentiable. Okay, when it is differentiable, if function is differentiable, then limit exists. What is limit? Limit is that dz, if I say dz by dx, dz by dx, that is nothing but delta z by delta x, that is nothing but when delta x leads to 0. That is limit that we see. Like if I say fxy, then d, if I am calculating the derivative along x-axis, then dfx plus delta x y minus d fx plus del dfx by dz by dx. This is what we want. Dfxy by dx. Then dfx plus delta x y minus, sorry, I want dfxy by dx equal to fx plus delta x y minus fxy divided by delta x, where delta x tends to 0. So that is the scenario. Now that suppose that fxy, okay, so this is the kind of formula for calculating the differentiation. If it is valid, okay, so fx plus delta xy, if that is valid, fxy I know it is valid, but if x plus delta xy is valid, then only we can calculate the differentiation. Now, if there is a hole, then f x plus delta x does not exist because there is a hole. Or if there is no hole, then at x plus delta x there is a mountain. Z value is very high immediately. Then also it is not a continuous. In that scenario, limit delta x tends to 0 does not exist. Okay, now we will consider this is differentiation. Let's see in the way for the continuity. Now if there is a point a comma b, now I want to know that this plane is continuous at a comma b or not. Now if I say there is any point x and y, then fxy more or less it should be equal to fab. Okay, fxy should be more or less, it should be equal to fab if x and y tends to a. Same thing I am saying. Okay, earlier I talked about differentiability, where dfxy by dx, that is nothing but fx plus delta x y minus fxy by delta x. Okay, if it is there is a whole, then x plus delta x delta x does not exist. If there is a sharp change in the z value, then fx plus delta x y does not exist. Now we'll talk about continuity in the term of the equation 1. Suppose that we want to test the continuity at a comma b. If I want to test continuity at a comma b, then the generic function that is in the function of fxy, generic function is fxy. Fxy should be tends to equal to fab. Xy is a point, ab is a point, a comma b, x comma y. There are 2 points. Now function over xy and function over ab, okay, means z vertical value at xy and vertical value at a comma b. fxy tends to match fab if xy is very near to ab. If x and y, that is limit, that is delta x equal tends to 0. This is what we say. So differentiation is nothing but delta z by delta x. Okay, but we can make it as differentiable when delta x tends to 0. If it is valid, then it is differentiable. Same thing we are saying now, that fab is a z value for ab, fxy is the z value for xy. They should be equal around if x comma y tends to very near to a comma b. If that is the situation, then the function is considered as continuous. It should be differentiable. Okay, what is the hodgepodge we did? Okay, the hodgepodge, or what is the kind of nonsense we get? Like if I'm calculating, this is point called AB. Now if x and y they are approaching AB, then fxy should be fab. That is the concept. If this is the point, then how we can approach? If it is 2D, then I can approach from all directions, 360 directions. Okay, so concentrate here. If this is the point, if this is the point, okay, this is a comma b, where x comma y is all around the a comma b. If they approach near ab, okay, and they are very near to ab, then the value of z at ab and value of z at xy, that is very near to ab, should be same, or there should not be sharp distance. Means the plane should be continuous. If that is the case, then it is differentiable. So fxy should be tends to equal to fab if x comma y tends to equal to a comma b. But if it is a dot b, then xy can approach a comma b from any direction, all 360 degrees. Okay, from all 360 degree, if they approach x and approach a comma b, then it is differentiable. If they approach a dot b and during the approach their value differs, okay, if it is approaching from x direction and it reaching a dot b, then while reaching a dot b I have some value. If it is approaching from y direction a dot b, while reaching a dot b I have another value, then this function is not continuous, because when they are very near to a comma b, at that time function fxy tends to equal to fab. Okay, so we will talk on this. So this is limit and continuity in differentiation. It has big story. Okay, later we will see the partial differentiation and everything. Basic calculus. This comes in basic calculus. We started with a person is walking simple 5 kilometer per hour. At the end of 10 kilometer, he is collecting 50 kilometer. If he is walking at time t, every hour he is increasing the velocity. At the end of 10 kilometers, his speed is 10 kilometers per hour. At the end of 2 hour, second hour, his speed is 2 kilometers per hour. Then how much he has collected at the end of 10 kilometers? That formed the equation as v equal to 2. So velocity is equal to time. If it is at the end of fifth hour, velocity is 5 kilometers per hour. In that way, so we calculated the area or we integrated it. If we integrate it, whatever we receive, it is equation. Then if we differentiate it, it becomes the that formula again. So how we can say that a function is differentiable? A function is differentiable only when it is continuous. That is basic requirement. So a function is continuous only when there is no hole, first thing. And second thing, the function over xy, the function over xy, the whatever value it is returning, at any point AB, it should return the same value if I move around AB delta. Around A comma B, if I move delta, that is very small, if I move around AB, then the function over those points should be similar. It should not be drastic change. If there is drastic change, like I am going nicely and suddenly I hit a mountain. So at the base of the mountain, one side, if I calculate fxy another value, other side it is sudden high. So that is not, it is not continuous, right? Means if there is a hole, after point there is sudden hole down, then it is not continuous. After point sudden mountain, it is not continuous. So for differentiability, the function has to be continuous. Then how we can calculate the function is continuous or not? So we gave the formula that fx plus delta xy minus fxy by delta x, okay, should return a value where it should be valid for the any delta x. Then f x comma y plus delta y minus fxy by delta y. It should return same value for any value of y. Means if I are approaching from x direction or y direction, then the differentiability, the value should be same. So this is differentiability, or the fxy should be fab more or less if xy is very near to ab. So then we'll proceed more on it. So this is limit and continuity in basic calculus differentiation. So that means, okay, so it is really hot here. So today, so we will have something for the breaking the hot. Okay, it har wahed har. Okay, it is lahub. Okay, so to break it, so we have kind of it is melon again, but it is not the musk melon what we brought it. I think it is called cantaloupe or something like English, but here it is abundant and it is not costly. It is very cheap. So that we'll try. Amazing. It is really like honey. Means it is very sweet. I don't know how it is very sweet. That can be different story, but it is very sweet. You will get seed. You can see the seed. Okay, this is how it is. Good water and sweet water. Okay, so be continuous in life and be differentiable.